data science could be seen as the bastard child between science and maths and computer science and programming, or increasing processing power, increasing storage space, interconnectedness has meant that suddenly we have large amounts of data we can use and mine for information. The fairy godmother to this child is economics, obviously, at the scale of organizations. We rarely seek information and knowledge just for the sake of it. When we want insights, it is because we have an objective or we have metrics. And when we transform data, it's usually to make a process more efficient and ultimately save money. So there is always an agenda. It's not pure science, it's data science. And this is why we always have to be very careful to be a little bit rigorous, because it's very easy to go this way. Don't know if you've seen this XKCD. Basically, you stir the data pile until you reach the results you want to reach, which is obviously not exactly how you want to do it. But yes, today I'm going to talk about the return of Clojure data science. Why do I say the return? It's because there was clearly a sort of golden age, a sort of rush of enthusiasm a few years ago. And Incanter came to be, and Guerrilla Notebook, etc. But since then, things have died down a bit. And when you want to do data science, you usually reach for Python or R or Julia or Octave, but not necessarily Clojure. And that sort of bothered us. So I work for a company called Mastodon C. It's a London-based consultancy, though largely remote as well. I'm a remote worker. And we were building a product to support city decision-making. And we also do some data consultancy on the side. And so a large part of our day job is, I guess, data science and working with data. And we noticed that while our production code is Clojure, and we use quite a lot of Clojure script as well, when it came to data exploration, we did reach for R instead. And our CTO, Bruce Durling, is like a big Clojure advocate, and he would rather have the whole process in Clojure, obviously, which is also easier to share between different members of the team. You just have to learn one language. Also, Clojure, code is data, etc. So it's, you can see there's a fit there, maybe. My talk is going to be structured as follows. Some talk about the basic tooling we started using to do data exploration with Clojure, the data structures, a couple of examples if I have time, a possible roadmap, open for discussion, so very happy to discuss later, and credits. Obviously, this talk is about our experience, and you may have a different opinion, which is perfectly legitimate. So basic tooling. Since we're talking about data exploration, we're not going to be talking about big data. We're going to be talking about not small data, but what we call awkward size data, which is like data which fits in the RAM, but possibly slightly exceeds Excel spreadsheet level, so maybe a couple of gig. And if you want to do data exploration on a very large data set, obviously you're going to do sampling anyway, because you don't want to wait for the night to have a few graphs of how everything is distributed. So, and then you're going to use sampling, and there's Clojure library for that. Even sampling that doesn't necessarily store your data in memory. So data science is about making sense of data, but it's mostly about making sense of data with that agenda in mind for other people. So it's all about communication. It's a bit like programming, really. You want to do some magic on the data, but you also want to immediately explain it to other people. And that's why notebooks are fantastic, because notebooks mean you you have a sort of running explanation, and you save your outputs as well in the notebook. And at the end, you practically have a report you can share with other people. And so we tried a few notebooks. Actually, the most well-known open source notebook we found out there is Jupyter, which is built in Python and was originally built only for Python, but now you can do R and other languages in it. So you can also use Clojure. There's a Clojure kernel, but I found it fairly awkward to work with dependencies. You have to do some dynamic loading magic, which didn't work first time around for me, at least. Then there's Beaker, which has a very nice, slick look and has some communication between Clojure and Java. So that means you can use its facilities for representing graphs, for instance, fairly easily. Again, it was pinned down at Clojure 1.7, and we're quite keen on moving forward from that, which meant intervening, which we didn't really want to do. And also the sort of Clojure to JavaScript situation made us a little bit uneasy. So the thing we settled with is Guerrilla REPL. Guerrilla REPL is mostly Clojure and a front end which has a WebSocket interaction with a REPL in the back end. And it's quite handy because it's just a lining and plugin. So you include that in your project. You do line, Guerrilla, port, whatever. And then you have your web page and you can just start working and evaluate everything with Shift-Enter. And it's quite easy and interactive, and it has a few shortcuts, which are good. It's not perfect. We'd quite like, for instance, a Clojure script front end, and it could be rewritten, and upgrading to 1.9 seems to be a bit of a difficult one because there's some interesting hacks in there. But it's good. Then let's talk about data structures. So in R specifically, which we have quite a lot of experience with, you work with data frames, which is like a certain data structure you can do a number of methods or functions on. And it's made to work with like a number of observations and a number of features. It's basically a kind of a matrix with labels. And there was an effort inspired on that in core.matrix.dataset. However, it's quite a sort of involved structure. Like this is only part of the definition. There's like, 10 interfaces in there, and I've tried to make some tools for it, but it's a little bit hard work. And so we come back to, sorry, actually skipping. And so yeah, I found it very complicated. And coincidentally, that's also the choice Incanter made to work with that core.matrix dataset. They decided to first they had their own data structures, and then they sort of branched into a core.matrix dataset. So here you can see the commit sort of numbers for Incanter, and you can see there's a big rush of enthusiasm in 2010. And then that's when David Edgar Liebke started the project and did quite a lot of good work. Then in 2013-ish, I think Mike Anderson, who is from core.matrix fame, came to it and started reworking it so it would use core.matrix datasets. And then it sort of died down. You can see that in 2016, 2017, there may be a few patches, but there's not much more happening. So I'm not in love with Incanter. It's the best player. It was the best player in town. It has a structure which I find awkward. It has lots of modules embedded in the project, and but it's also it uses its own sort of awkward data structures, and so while there's good bits in there, I don't feel compelled to use it because it feels like you have to immediately take on board a lot of baggage. And so I'm sort of a proponent of plain old Clojure data structures, which is basically vectors of maps. If you want to be more efficient, then maybe you can make it vectors of vectors, but for our awkward size data, vectors of maps works perfectly fine. And that means that you can start using Clojure spec, for instance, to validate your data fairly easily, which is nice because validating your data or checking whether it's valid is part of the job, big part of the job. And you can also write your own conformers or coercers to transform it to where you want to be, to where it's useful for you. Then there's, with vectors of maps, we can obviously use our transducers straight away. And one of my colleagues, Henry Garner, has developed a really nice library of statistical transducers called KickSee Stats. So it gives you a lot of nice things to start your analysis with. Like, for instance, here, we want to find the correlation matrix between X and Y and Z. And it just gives you that, and very, very efficiently, which is nice. And obviously, you have the whole world of transducers to combine and mix and match and play with your transducers. So you have XForm, Redux, and Huard is actually a library by Simon Belak, which aims to make data science fairly easy. And I've not actually dug into it very much, but I think there are a few gems in there, which could be very handy as well. Interestingly, he took a different route, but came to the same conclusion as we did, which was that vectors of maps are really the way to go if you want to do Clojure data science, or data exploration at least. Then let's come to an example. My first example is based on the Kaggle datasets. How many of you are aware of Kaggle? Okay, quite a few people. So Kaggle has data competitions, but it also exposes a number of public data sets for people to play with and explore. And the one I chose was universal basic income, which is the idea that we should pay everyone a sort of minimum basic level of income. So let's say everyone in this room would get €1,000 a month, whatever they did, whether they sat at home or whether they decided to go and work and supplemented income with something else, which is interesting. But you see, I started a Guerrilla Notebook where I give some explanation. What is this data set? Where does it come from? How many records does it have? 28 countries of the European Union. Okay, let's start some dependencies. You see, it's a bit like just starting some code, except you can make it nicer. Although you can also do that with Emacs, to be fair, with org mode, but it won't save your output, which is what is missing for Emacs. Then, okay, let's have a visual check. What does this data look like? Display a few records. I find myself reading vectors of map quite painful, so I wrote a wee plugin that just makes it a table. Then let's visualize some things, like how many people vote for the income, how many people vote against, and how many people don't care or have no opinion. And you see there, the graph is not amazing. So what I did there was farm out to R. Basically, I used a plugin, the writer of Guerrilla REPL, Johnny Hudson, wrote, which is basically shelling out to R and then importing the output of R. So that's one point that I think Guerrilla REPL could be improved on, and I've started playing around with using Thing, Geom, to have nicer graphs. And Huard also does some work, but I think it still shells out to R, which I think is a shame. Everything should be in Clojure, in my opinion. But so we have a few visualizations. then it becomes really easy to sort of see, to sort of analyze and process this data with your usual box standard Clojure. So what I do here is filter out the part of people who voted for, then sort of reduce and sort, and then we can see why people voted for universal basic income. First reason, it reduces anxiety about basic financing needs, obviously. Then the people who voted against, what are their reasons? Also fairly easy to extract, and how many voted for that. It might encourage people to stop working. That's legitimate as well. And then what are the correlations between the factors, which is slightly what is interesting. So we have data about the demographics, so age, whether they have children, whether they're rural, whether they have an education level, etc. And because I like to live dangerously, I whipped up a little transducer for the Kramer's V, which is a stat to tell you how nominal factors are correlated. And it's between 0 and 1. And if it's 0, there's probably no correlation. And if there's 1, then they're basically the same data. And you see that there's some correlation between vote and awareness, and some correlation between the vote and the country people are from. The rest is fairly weak. And the last number was a sense check, which is a correlation between age group and whether the group has children. Obviously, people will have children in certain age groups, so there will be a correlation there, and that's what comes out of this as well. So that was one example. You see, all this is fairly sort of friendly, and even better with Guerrilla REPL, you can also CIDR connect from your Emacs and sort of have helper libraries in your normal Emacs and REPL situation, so that your end result, the notebook, only contains the code you really want to display. Very easy to work with. Then our next example is a bit more on the showy side, and full disclosure, it's not my example. I run an example from the Cortex library. So interestingly, for neural networks, which are very, very fashionable right now, you have already two players in the Clojure universe, which is Cortex, also partially written by Mike Anderson, who did Core Matrix, and a deep learning 4G, which is really Java library, but has Clojure bindings. The example I'm going to talk about is recognizing handwritten digits. This is like the textbook example for neural networks. If you have any course on neural networks, that's what you're going to learn. You see Cortex has a very nice DSL to represent a neural network. Here they're going to choose a convolutional neural network. So when you learn it in textbooks, handwritten digits are usually analyzed with a perceptron, which is a very simple sort of feed-forward neural networks. Convolutional networks are a bit closer to the visual cortex in that the neighboring cells are more interconnected, and you also have a more 3D structure of neurons. And that works apparently even better. And what is really, really nice with Cortex, I was really wowed by that, is that when you use the train forever function, so you define your network and then you give it the input and you train forever, then it opens a web page with Clojure scripts, and that Clojure script shows you the progress of your training. So here you have a confusion matrix which shows how well the digits are classified, whether 0 is classified as 0, 1 is classified as 1 as well, and to what percentage, etc., how many. And so you see this evolving. You see, this is a dynamical page that is just evolving as you look, which is amazing. And you can also see the accuracy with every iteration. You can see it's sort of progressing. And you also have a visual field that shows you how the handwritten digits are classified. So that was really nice, and I'll definitely go back to that one again. Unfortunately, there isn't that much showy, I guess, going on in Clojure yet. And so that's why we could use what other people have done in Java. My colleague, Henry Garner, again, did a fantastic set of bindings for mallets. Mallets, we use that quite heavily for topic analysis of texts. And it's doing really well. However, there are so many other things out there. There's Weka, there's XGBoost, which is so Weka is for also natural language processing. XGBoost is for gradient boosting, which is basically you use a set of weak learners together to produce a nicer, a better results for your classification. And so that there is a long list of bindings that could be used and transformed into nice Clojure libraries. So as a roadmap, I would like to propose the following. Again, open to discussion. Notebooks. So Guerrilla REPL, really nice. Needs to be upgraded. Could be improved, and maybe there's better options that could be made. I quite like how it interacts with your Emacs REPL, your CIDR, and it makes it very easy. But it's not perfect. The graphs could be much improved. The design could be possibly improved as well. It's not massively slick, etc. So, and also the delivery, because now it's possible to use a viewer to represent it as a web page. But it would be nice to say export a PDF very easily or export the graphs very easily, etc. That would make it much easier to work with and produce outputs. So that's one thing. Then obviously our statistic and tooling will continue to grow. We're definitely going to continue to work on that. But pull requests welcome. Then Incanter has a lot of nice stuff in there, in between all the modules, etc. So if you ditch the data structure, if you ditch the graphs, etc., there's probably a lot of stats that have already been coded there, and which potentially can be extracted and transformed for good use. That's my feeling, at least. And then obviously we want more nice tooling from the Java world. That would be really nice. Or if you feel very, very brave and are very good at mathematics, and then obviously writing it from Clojure from scratch is also an option. So this presentation is standing on the shoulder of giants, as they say. The author of Incanter, David Edgar Liebke, Michael Anderson, cited multiple times, Core Matrix. Johnny Hudson, who wrote Guerrilla REPL and now works for DeepMind, so he has no longer time to work on this, obviously. And then Karen Meyer did some really good blog posts, and it's also an ongoing interest for her. Simon Bellag did some good presentations, and he's also working on it and has his own library, Huard. So that's it, and thank you for listening, and any questions?